Welcome to solverfy.
All right, so this is the question they asked in my interview, so I'll just quickly solve this question here. So in this question, they want to figure out a problem involving sick days for workers. And the researcher wishes to see if the average number of sick days a worker takes per year is greater than 5. So let's plug in all the data they give us. So first we know that n, the sample size, equals 32. Next we have that the standard deviation of the population, so we'll call that sigma, equals 1.2. The alpha level for this test is going to be 0.01, and the mean for our sample, so x bar, equals 5.6. So let's look at our hypotheses for this test now. So the researcher wants to see if the sick days of workers on average is greater than 5. But the null hypothesis is basically the given. So here the given would be that mu, which is the average number of sick days, equals 5. And the alternative hypothesis would be that mu is greater than 5. Now, to move on to the test, we have to calculate a z statistic. So to calculate this, we'll just use this formula right here, which is just the x bar minus mu naught divided by the standard deviation of the population divided by the square root of the sample size. So plugging that in, we get that z equals x bar, which is 5.6, so 5.6 minus mu naught, which is 5, divided by the standard deviation, which is 1.2, divided by the square root of 32. So next, you just plug this into a calculator, and if you plug this into a calculator, you will get, I should have probably done this beforehand, so I'm just quickly calculate this right now. You will get 2.83. So this equals to approximately 2.83. Now that we have our z value that we've calculated here, we have to compare it to the z value for an alpha of 0.01. So what's actually going on here is that for the test, we're going to assume that our null hypothesis is true. That's how they work. So if we plot our normal distribution, it will look like this, with the center being our mu naught of 5. And the alpha of 0.001 refers to this area right here, which is an area of 0.01, which means that all of this area is 0.99. So the z value we found was 2.83, and we need to compare it to the z value of an alpha of 0.01, which is the number we find right here. How do we get that value? Well, there's two main ways I use. The first way, the most common way, is to look at a z-table. And we'll look at the z-table and look for an area of 0.99, because this is a one-sided test. Now, this was a two-sided test, which would mean that instead of having greater than 5 here, we would have not equal to. Then this would be a two-sided test. But here, because it's greater than directional, it's one-sided. So this was less than, instead, it would be this area down here. So going back to this, if you look into a z-table, we will get that this z-score is approximately equal to 2.33. Now, another way I use, which is a more exact way, is to go into Excel and a simple formula called equal norm inv, and your parameter is a probability. So if you're good at Excel, you can quickly just open up an Excel tab, put in this formula, and plug in the value here for your p, and that will shoot out this z-score. So now we have to compare this z value and that z value. And why are we comparing them? Well, to either reject or fail to reject hard null hypothesis. Now, we reject the null hypothesis in the case where the z value that we calculate, so the z value we calculate, is greater than the z value for that given alpha level. And we fail to reject the null hypothesis when the z value we calculate is less than the z value for the alpha given. So in this case, our value of 2.83 is greater than 2.33. Thus, we're going to reject our null hypothesis, which means that we reject the fact that mu equals 5. So going back to the question at hand, where it's asked if there's enough evidence to support the researcher's claim that alpha equals 0.01, the answer is yes. There's enough evidence. There's enough evidence to support the researcher's claim at an alpha of 0.01.